So in this video, we will be talking about supervised learning. Let us understand what is it and the basics of supervised learning. So what is supervised learning? So supervised learning is a subcategory of machine learning in which the algorithm solves a certain problem in the presence of a teacher. This teacher is nothing but some data or information with labels assigned to it, and these are assigned usually by humans. So to create an analogy, supervised learning then can be considered equivalent to learning in a classroom environment. So, in a classroom environment, there are two methods to learn to solve a problem. The one is to learn by the help of a book, and the other is to learn with the help of a teacher. So, whenever you solve a problem with the help of a teacher, by when you understand the problem with the help of a teacher, it can be considered as supervised learning. So, this information or data is called the label data and has two primary attributes: the features, inputs, samples, and attributes, and the second one is the target, output, or label. So the features or the inputs help the algorithm to figure out what is the method by which we want to learn the target output or the label. So some common examples of supervised learning problems are image classification, text recognition, weather prediction, and stock market forecasting. There are many other examples, but these are some of the most prominent ones. So what is label data? So it is a type of data in which meaningful labels are assigned to different samples of items. So in the sample of images, we can consider animals as the labels. For example, labels can be cat, dog, lion, tiger, or anything. In the sample of records of patients, labels can be whether the patient has a disease or not. So, for example, if you have a data of patient's profile having BP, glucose, and sugar levels, so the labels for them can be whether the person has a disease, a diabetes disease or not. So mathematically, label data can be represented as a pair of input or output variables and can be denoted by the set uh, tuple of x1 comma y1, where x1 is the feature or the attribute and y1 is the target label or the output label. So x1, y1, x2, y2, x3, y3. So with the help of this x1, we want to figure out what is the predict the value of y1. So there are different types of data. Let us understand what are the different types of data available to us. So one is the categorical data. So in this type of data, the target or the feature variables come from a set of symbols. For example, yes, no, male, female, etc. So for example, if you have a data of say whether a pregnancy record of a woman, so in that, so for example, if a woman has a disease or not, so the X labels can be one of the features can be whether the woman had a disease previously, uh, or whether she smoked or drunk alcohol. So yes or no in that case. So this is one of the examples of categorical data. Another is the numerical data. So in this type of data, the target or the feature variable can take any number or integer value. So for example, age, marks of student, temperature of a certain city, etc. And again, on the based on the type of target variable, supervised learning can be categorized again as classification. So in the case the target variable is categorical again. So for example, in the case of image classification, if you want to predict whether the given image is of a cat or a lion or a dog, then the target variable is a categorical variable. So in this case, we want to classify whether the given image is of a animal or not. So it is a classification example. The second one is regression. So in the case, the target variable is numerical. So for example, if you want to predict the stock market based on some different features, so for example, market volatility and the previous day price. So and we want to predict the closing price of a stock. So then that case is of regression. So in this in the stock market case, the output label can take any positive value from say not usually zero, but from zero to any possible value. So now, what is the representation of data? So if we want to figure out the mathematics behind the algorithms, we want to have a specific representation for the data. So our representation for the data is of a matrix form. So these x1, x2, xk, these refers to the samples or the attributes, and this y represents the target label. So the small x1, x2, xn represents the number of the samples available to us. So x1 is the first sample, and assume we have n samples. So x1, x2, xn are the samples. Then x11 is the first sample, first attribute. X12 is the attribute 2 related to the first sample. Similarly, x1k will be the attribute k with respect to the first sample. Similarly, y1 is the output label corresponding to sample x1. Then x21 is again the attribute 2 corresponding attribute 1 corresponding to sample 2, and so on. So this is the mathematical representation for data, and it can be represented in a tabular or a matrix form. So x1, x2, xk are the feature variables, and the y is the target variable. X1, x2, xn are the samples of data, and y1, y2, yn are the corresponding labels. So this is all about the basics of supervised learning. In the next video, we'll talk about more about the representation of data and how to deal with the this data and create and help with the help of this data how we can learn different algorithms.